Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 8, Section 3, and this is Part 4B. So we're going to finish up talking about intermolecular forces, and we're going to talk about the type of intermolecular force that is found between nonpolar and nonpolar molecules. So that's called London dispersion force. And what is it? So please write this down. The attraction between nonpolar molecules due to the momentary polarization of the molecule due to the movement of electrons. Okay, so let's break that down just a little bit. It is an intermolecular force in nonpolar molecules. It is caused by the movement of electrons. It is a temporary and a weak force. So when we have electrons zipping around, at one point they'll be over here, or maybe at another point they'll be over here or over here. So at this one point, if the electrons are, let's say, over here, then it's partially negative on this side of the molecule and it would be partially positive on this side of the molecule. Well, let's just say maybe at one instance this other molecule has its electrons zipping around and they happen to be over here, so then this is going to be partially negative. So for that split second, this partially negative part of the molecule is attracted to this, let's say, partially positive part of the molecule. So that is the London dispersion force, and after a split second it's gone, but what we know is that it'll form here and then break. It'll form here and then it'll break. It'll form here and it'll break. And there's enough of it going on in the whole substance that it makes a difference. And what does it make a difference about? Well, it allows nonpolar substances to be liquid or solid. So if there were no London dispersion forces, all nonpolar substances would be gas. And that's not true. We have liquid olive oil, we have solid butter, we have solid animal fat, and on ourselves, including other animals, and that's all because of intermolecular forces, these London dispersion forces, which are the momentary attraction between a partially positive part of this molecule that because the electrons are over there for that split second. So I think that's kind of fun. And our example is butter. And then on page 249, there is a nice example telling us the difference between butter and oil. And we will look at that. All right. I will see you later. Bye.